Today we will solve the problem 3.41 of Griffith third edition Introduction to Quantum Mechanics. The problem 3.41 is a harmonic oscillator is in a state such that the measurement of energy would yield of h cross omega or 3 by 2 h cross omega with equal probability. What is the largest possible value of the expectation value of P in such a state? If it assumes this maximal value at t equal to 0, what is psi of x and t? So we have to find the answer for this. Here it is given the energy of harmonic oscillator is of h cross omega. So generally nth state energy of harmonic oscillator is, you know very well, this is n plus of h cross omega. So for h cross omega, n must be 0. So ground ground state energy, that is of h cross omega. Then next excited state, if n is equal to 1, then you will get 3 by 2 h cross omega. So we will take the linear combination of ground state and first state. So psi of x and 0 is equal to C naught, some expansion coefficient C naught psi naught plus C1 psi 1. Now you have to find the time dependent wave function. So the time dependent wave function is psi of x and t is equal to C naught psi 1 e power minus I E naught t over h cross. So here we are including the time factor. For first one and for second one, it is e power minus I E1 t over h cross. Here both have equal probability. That is C naught modulus square of C naught is equal to modulus square of C1, which is equal to half, because both are having equal probability. Then generally C naught can be written as e power I theta 0 over square root 2. Here this is the phase factor. Similarly, C1 is equal to e power I theta 1 over square root of 2. Now we will move on further. We have taken the total wave function as capital psi of x and t is equal to c naught psi naught e power minus I E naught t over h cross plus c1 psi 1 e power minus I E1 t over h cross. Then you take complex conjugate of this. So this expansion coefficient will become complex conjugate of it, and wave function also. And this exponential term, here you have minus negative sign, here you will get positive sign if you take complex conjugate. And if you take the product, you will get C modulus square of C naught into modulus square of the psi naught as plus modulus square of C1 plus multiplied by modulus square of psi 1 into, now you take, this is a product of self term. If you multiply the cross term, that is the first term of this and the second term of this, you will get C naught star C1 psi naught star psi 1 e power I E naught minus E1 t h cross. Then this C1 star, if you take C1 star C1 star C naught, C1 star C naught, this term and this second term and this first term, you will get C1 star C naught psi 1 star psi naught e power I E1 minus E0 E sub 0 multiplied by T over H cross. In the first two terms, this exponential term will get cancelled because here it is plus, here it is minus. With that thing, we will move further. Now, our aim is we have to find the expectation value of momentum. So, by definition, this expectation value of momentum is capital psi P, that is bra vector, bra psi and P and get psi. If you take this to the right hand side, you take first term, what will happen? This will be C naught C naught square, of course, modulus C naught square. This term we can take psi naught, bra psi naught. Then this P, time being you forgot this square root term. So you take inner product with A dagger minus A with same psi naught. What will happen if you take when annihilation operator acts on psi naught, it cannot go below psi naught because it's a ground state energy, it will be 0. If A dagger creation operator act on psi naught, it will become psi 1. Then inner product of psi naught with the psi 1 will become 0. So whatever may be the case, this will become 0. That is the first one will become 0. This will become 0. Then in similar argument, this also will become 0. Now the existing term is second and third. You can substitute this P equal to I square root of H cross M omega over 2 A dagger minus A. We will come to it later. First you take the first term. Now if you take the expectation value of P, then we have seen that C naught, at the beginning of our lecture we have seen C naught is equal to this one. This is C naught. It's C naught complex conjugate. C naught is, because this exponential become minus, C naught is equal to e power I theta. We have seen this is the phase factor divided by square root 2. So that complex conjugate of this means plus I will become minus I, and C1 is remaining thing is this is C1. The second term is C1. So next you have to take inner product of psi naught with psi 1, psi naught with psi 1. So then this exponential term will come automatically. Same thing, you apply C1 star. C1 star is a complex conjugate of C1. We know, we have seen C1 is equal to e power, sorry, here it is theta 0. So e power I theta 1 over square root 2. If we take complex conjugate of this, e power minus I theta 1 over square root of 2, then C naught. C naught we have seen here, e power I theta theta 0 over square root of 2. Then this psi 1, inner product of psi 1, because it is complex conjugate, that is a bra vector. P psi naught get vector, then this exponential term I have taken. Now you group the, simplify the term. In the denominator you have square root of 2 into square root of 2, which will become 2. In the numerator it can be written as e power I. Here theta 1 is plus and theta 0 is minus. So theta 1 minus theta 0. Then what is E1 minus E2? That is a first excited state and ground state difference, energy difference, divided by H cross is equal to omega. So naturally this will be in the other way around, E0 minus E1. So this will be minus omega. So it can be written as, this exponential term can be written as e power minus I omega t. Apply the same thing here. That is e, if you combine the numerator, e power I, this is plus theta 0 minus theta 1, this one, divided by 2, and this is psi 1 p psi naught, and this will become naturally the E1 minus E2 over H cross is omega. So omega is here I have mentioned, so no problem. E1 minus E0 over H cross is omega. So this will become e power I omega t. We have seen the expectation value of momentum is equal to e power I theta 1 minus theta 0 over 2. Then the inner product of psi naught with p psi 1 and multiplied by exponential term e power minus I omega t. Then the same thing plus e power I theta naught minus theta 1 over 2 psi 1 inner product of psi 1 with p psi 0 and multiplied by exponential e power I omega t. Now we know the p is equal to I square root of h cross m omega by 2 a dagger minus a. So now you take this one, first inner product. I have taken the first inner product and I am replacing this by its operator in harmonic oscillator, which is this is constant. I square root of m omega over 2 is a constant I am taking out, and I am plugging this a dagger minus a inside this inner product. When a dagger act on this a, remember that a dagger act on psi 1, this get vector, it reduces the state to 1 by 1, giving the expansion coefficient square root of n. Here square root of n is equal to, n is 1, so this will be 1, square root of 1. So square root of 1 is 1, don't worry about it. Then you will get, this will become psi 0 when it's act on a, act on psi 1, psi naught. Here you have negative sign. Inner product of psi naught with the psi naught is 1. Of course, you have negative sign, minus. So this square root also 1, so don't worry about it. At the result, you will get minus I, because this minus comes from here. I is square root of m h cross m omega over 2. Remember that when a dagger act on site 1, it raises the energy by 1, that is it will become psi 2. Inner product of psi 1 psi naught with psi 2 is 0, so this will not contribute, this will become 0. So only contributing term is annihilation operator with expansion coefficient 1. So you will get the inner product of the first one is minus I square root of h cross m omega over 2. Then you take the next one, psi 1 p psi naught. So you do the same thing. I am taking I square root of h cross m omega by 2 outside, then a dagger minus a inside this inner product. When annihilation operator act on the psi naught, that is ground state wave function, it will be 0, so it will not contribute anything. Then what will happen if a dagger act on, that is creation operator act on psi naught, it raises its energy level by 1, that is psi 1 with the expansion coefficient n plus 1. Here n, initially n is 0, 0 plus 1 is 1. So square root of 1 is 1. So don't worry about it. This will contribute 1. Only this will contribute. Here annihilation operator contributed, here creation operator contribute. The inner product of psi 1 with the psi 1 is 1. So naturally the inner product is equal to I square root of h cross m omega over 2. Now you replace here. If you replace here, then in this case, first case, this inner product is minus I. Already I have 2 here, minus I over 2, then square root of h cross m omega by 2. I am combining this term with I am combining all the exponential terms. So then exponential minus I, this omega t minus, because already I have taken minus outside, this theta 1 will become minus theta 1, and this minus the theta 1 will become plus theta 1 naught. Minus theta naught will become plus theta naught because I have taken minus outside. Same with the second term. I have taken this I and this 2. I over 2, then square root of h cross m omega over 2, then this exponential term. I am combining all the exponential term. This will become e power I. Here you can see omega t. Then this is minus theta 1 plus theta 0. So the expectation value, I have found this. We have to reduce this. We will do the further simplification of this expression. So we got the expression for expectation value of momentum, which is equal to minus I over 2 square root of m h cross m omega by 2. Then this exponential e power minus I omega t minus theta 1 plus theta 2 plus I over 2 square root of m h cross m omega over 2 e power I omega t minus theta 1 plus theta 0. This is what we got. Now you take this constant outside. Here you have I over 2 square root of h cross omega by 2 here also. So I am taking I over 2 and the square root term, square root of h cross m omega by 2. Then the remaining term is, here you have minus, then this exponential term. Here you have plus this exponential term. This argument, you see the argument in the both the exponential term is same, except here it is negative, here it is positive. So that is e power I theta plus e power I theta minus e power, because here you have minus. So minus e power minus I theta is equal to, by definition, is equal to 2I sin theta. You know this relation. Now this can be simplified as the entire term inside the bracket can be simplified as 2I sin omega t plus theta. I brought theta naught first, plus theta 0 minus theta 1. Now here this 2 will get cancelled, and you have I here and I here. I squared is minus 1. So I have taken minus square root of h cross m omega over 2. Then here the sinusoidal term I have taken as it is, sin omega t plus theta naught minus theta 1. Then we will find the maximum value of momentum, expectation value of momentum. The expectation value of momentum is equal to minus square root of h cross m omega over 2 sine omega t plus theta naught minus theta 1. So when you will at time t equal to 0, we will get maximum value as given in problem. What is the maximum value at the time t equal to 0? At the time t equal to 0, this term will become 0. So you will get minus square root of h cross omega over 2 sine theta 0 minus theta 1 because t is 0. Now when you will get this maximum, when this sine theta 1 theta naught minus theta 1 is equal to minus 1. Remember that there is a minus sign here. So in that case, the expectation value of momentum, maximum expectation value of momentum is when you will get when sine theta naught minus theta 1 is equal to minus 1. So this is the maximum value when it is possible, that is sine theta 0 minus theta 1 must be 1. Minus 1, sorry, must be minus 1. When it happens, when theta naught minus theta 1 is equal to pi by 2. Phase difference is pi, minus pi by 2. 1 minute. This is equal to minus pi by 2. That case, sine pi by 2 is 1. Sine minus theta is equal to minus sine theta. So it's an odd function. So it must be minus pi by 2. So the space factor must be minus pi by 2, or theta naught is equal to theta 1 minus, if you bring theta 1 that side, you will get minus pi by 2. You will get somehow it must be augment of sine must be minus pi by 2. So in that case you will get a maximum value of h cross m omega over 2. Now what is the wave function at the maximum expectation value of momentum? So it's a linear combination of two wave function, that is ground state wave function and first excited state wave function. That is, it can be written as 1 over square root 2. This is normalization constant. Psi naught e power minus I omega t by 2. Because we are seeing the ground state energy as given in problem, it is h cross omega first and 3 by 2 h cross omega. So the next term will become psi 1 e power minus I 3 omega t over 2. That is 3 by 2 omega. Then the space factor. You don't forget the space factor. The space factor must be minus pi by 2. So in the exponential form, I have written this is e power minus I pi by 2. This is the wave function at any time to get, in order to get the maximum expectation value of momentum. Thank you very much for watching my video and supporting me continuously. Thank you very much.